At Siam Metal CNC, the stakes of production are visible in the finished product, a single, high-precision aerospace component worth 50,000 baht. But that value is fragile. If a cutting tool snaps without warning, it doesn't just ruin the part, it crashes the machine's motor, stopping the line for days. Even when the machines are running, invisible errors can be just as costly. Hair-thin scratches that pass a manual inspection are often flagged by an international buyer's high-end scanners, leading to massive contract fines. In this world of extreme precision, unseen errors, whether structural or cosmetic, cost millions, and traditional oversight is no longer enough to catch them. Part of the problem is biological. Human focus begins to degrade after just 20 to 30 minutes of repetitive inspection. This fatigue is exactly how defects escape the factory floor. Then there is the mechanical blind spot. Traditional maintenance relies on fixed schedules that, as this timeline shows, a part scheduled for a 6-month replacement can easily fail in month 4, leaving the factory completely unprotected. Standard automation can't fill these gaps because it relies on rigid if-then rules. It only knows how to react to problems a programmer specifically told it to look for. To reach zero defects, a factory cannot rely on static rules or tired eyes. It needs a system that learns from its own history to predict what happens next. Machine learning changes the way we approach industrial logic. Instead of engineers writing every rule by hand, they feed the system vast amounts of historical data. The computer uses this data to build its own mathematical equations, finding the hidden patterns that connect a successful run to a catastrophic failure. The more data the system digests, the more accurate those equations become. By giving the factory a memory through the cloud and senses through IoT, machine learning acts as the central brain that processes it all. We can see this in action at Siam Metal, where vibration sensors are attached directly to the spindle of a CNC motor. During the training phase, the AI monitors microvibrations, frequencies the human ear can't detect. It learns to tell the difference between a healthy hum and the specific jagged frequency that signals a tool is about to snap. Once the AI identifies that doom frequency, it triggers an automated emergency stop, halting the machine milliseconds before the break occurs. This isn't just reacting to a break, it's forecasting it. The 50,000 baht part is saved because the machine knew it was in danger before it even touched the metal. Machine vision solves the problem of human fatigue by placing high-speed industrial cameras directly over the production line. Using deep learning, the system is fed over 1,000 images of those microscopic scratches until it can recognize the profile of a defect instantly. The camera scans every single part with zero exhaustion, signaling a robotic arm to pull flawed pieces off the belt the moment they appear. It provides the nuance of microscopic scrutiny with the relentless 24/7 endurance of a machine. Siam Metal achieved zero defects with this system, but it didn't mean firing the quality control team. Instead, those workers were upskilled. They moved from the repetitive task of manual sorting to becoming AI tutors, analyzing the data and refining the system's logic. However, getting to this point requires a reality check. AI is not a magic fix. It requires a very specific foundation. First, the data must be clean. If your sensors provide inaccurate information, the AI will provide inaccurate predictions. Humans must also define mathematically precise criteria for what counts as a defect before the system can learn. It must be deployed on critical bottlenecks, and operators have to be patient. An AI is like a student. Its accuracy starts low and climbs toward 99% over several months. AI succeeds only when it is backed by human discipline. It is a tool for amplifying management standards, not a way to bypass them. When all these pieces are in place, the factory gains a nervous system, a memory, and a brain. The futurist Alvin Toffler once noted that you cannot solve 21st century problems with 20th century thinking. The days of relying solely on a veteran mechanic's gut feeling are changing. That intuition is now being supported by advanced statistics, giving the factory floor a foundation of mathematical certainty. The true value of this technology isn't just the ability to fix problems faster. It's the power to see them coming and prevent them from ever happening.